Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this Developer Zone, and because of a lot of questions recently, we tend to now go bi-weekly, often on a Thursday and a Sunday. That said, I'll jump into it now. And what we try to do is we try to answer questions that have come in during the week, that have a sort of technical nature to them. So this week I am going to talk about pH sensors, and I feel like we're talking about pH sensors that are potentially embedded. So I will discuss that. And I'm also talking about cortisol measurements. I'm going to contrast really the ease of measuring cortisol in something like saliva, but I'll also put a case study up with the technology stack that we use to measure lactating sweat. Because the way I feel about it is the hardware and a lot of the lessons for measuring lactating sweat can also be applied to cortisol. But let me get to those questions in a little bit. A big emphasis these days at ZP is really getting people to MVP, minimally viable. I'm going to use a distinct term here, prototype. You've got to be careful with the term product because people can kind of over expect. But what we try to do is we try to get people to tangible hardware really quickly, especially when I look at question number 1 today, which is really about pH sensing. It's kind of like, in the end, most of what people are trying to do in this life, especially medical diagnostics, is innovative. There's almost no point in doing it unless it was innovative. Otherwise, it's already been done. There's lots of products on the market, and there's no scope for innovation. Getting that IP, getting that 20-year exclusivity, you might as well be doing something else. So a lot of questions. So at ZP, we understand that actually, really to make profit in the end in medical diagnostics, for example, you have to be innovative, and we're trying to really shorten that road to innovation and therefore productization. So I'll question number 1 in particular today is really of that kind of the questions really have to be answered during a program, but I'll get to it. Just to say as well, I think this is particularly applicable to probably question number 2, just to give you a better sense of our technology stack. And this is regarding cortisol. Then it's worth coming to the webinar on the 24th of January. We do one in the morning, one in the evening, our time. So the one in the morning works well for places like India, and the one in the evening works well for guys in California and in Texas, etc., because of the time zones. So, and if a link pops up, I'll try to remember to put the link underneath the video as well. Going forward, this is probably interesting to question number 1, because really, if the budget's in place, it's probably best to have sometimes these kind of large, we do workshops, we do these practical workshops where myself and an engineer turn up, we do talks, we do demos, we do hands-on, so everyone gets to make a biosensor and everyone gets to test the biosensor. And it's probably worth saying that in those workshops, everyone gets to test a pH sensor as well. I realize as I'm talking today, as I'm thinking at this moment, I'm thinking, oh crumbs. Well, actually, when it comes to pH sensing, this is one of the questions today. We actually have a lot of form factors. In fact, I didn't mean to. I wasn't really going to be showing this today, but we have. How do I describe it without having one in front of me? But we have. Oh, in fact, I do have pictures of it. We have form factors where the electrodes are primarily planar, essentially flat. So ZP is known for a kind of lot of these flat electrodes. We have form factors where the electrodes are essentially wires. And in fact, I do have an image of that today. And then I just happen to have this one here. It just stimulated me. It's very hard for you to see this, and I'm not expecting you to see it. But what I'm just indicating, in fact, it is in the notes today, microneedles as well. So now, question number 1 is interested in sort of in vivo pH sensing. So the microneedles are not so suitable. But everything they're looking at is about planar electrodes. And if I was making a smart embedded device, I think it's a good way to go. But it's probably worth saying that ZP also has other 3D form factors, which would also kind of work quite well. Which one you go for is not really a decision you can make off the web store. It's a decision you would really make with ZP in a program, in a paid program, because there's a very important subtlety to all these decision making, and you really can't do it via a sort of a sales process. I think you really have to kind of bite the bullet, get into a program, and let ZP contract into that program. Anyway, that said, this is still the intro to the webinar, so I need to go a little bit quicker. We do have a conference in June in the UK on the commercialization of electrochemical biosensors. I'll put a link here as well, and now I'll go a bit faster. Right, so question number 1, pH sensing. I put here in vivo and in vitro. I really think this is really about in vivo within the body. Question number 2, cortisol sensors. I put ex vivo here. What I really just mean is sensors potentially that are wearable, though I think to do cortisol is much easier to do it by doing it from saliva. If I'm looking for a non-invasive way, I do it by saliva. Though people are very interested in sweat. At the same time, we only need 50 microliters. So if somebody has sweated, 50 microliters is not too hard to get. If somebody's essentially dry, then it is quite hard to get potentially 50 microliters off them. Yeah, this is my first point. If I was trying to make a smart embedded pH sensor, I would actually be using this form factor, especially my R&D stages, because it really allows scalability in manufacturing. The questions that came in today, one person was interested in pH, the other was interested in cortisol. If you see the link here, I'll put there is a link here just off the screen, but I'll make sure I put that into the video as well. So question number 1, the first thing I would say is the reason the ZP web stores exist is really to buy and try for R&D purposes only. Now, what I mean by that statement is people can spend so much time, before there was a Zimmer and Peacock, answering the question, can I even make an embedded pH sensor? Can I even make it? You'd almost, there wasn't a solid state pH sensor out there on the market readily available, and there wasn't electronics to drive it out there on the market readily available. Now they are. So suddenly the question, do I even stand a chance here? You could call this a proof of concept, a POC. That's a NASA term, so it is an understood term. You can suddenly just do it. You go to the web store, you buy the materials, you start trying it. Because I think people spend so much time speculating and not taking the first step. So that's why the whole sort of Zimmer and Peacock exists to actually get people to market. But the web store exists just to kind of say, stop thinking about it, you can just do it. Now question number 1 here is, what's the operational time of the sensors? Can it be continuously used for prolonged periods for 6 months? So the web store exists with data, and lots of data, and I'll get to question number 1. I call this 1.1, and I will answer this. What is the sensor's lifetime in biocomplex solutions? With additional, I call that 1.2, I do answer that. Is it biocompatible? I mean, one thing I'd say about ZP is, the questioners are super aware that ZP is implanting sensor packages into fish. We're also doing it into mammalians. I happen to have a wearable transdermal sensor here, but the microneedles on this particular device, this is a watch. I'll just put it on. They actually go through the skin and into the interstitial fluid. So it's probably worth saying that most of what we do at ZP is designed along the ideas of biocompatibility. But for example, we're working on a large program at the moment, and into that large program, well-funded large program, there's a risk register. Everything goes in there. We go through it and we answer it all properly. I mean, so ZP, we're ISO 13485. And it's probably worth saying that the materials that we put on our web store, they're meant to get you going. They're not meant to then, you are, if you're really serious about doing a medical diagnostic, then you do have to engage with ZP a lot deeper than this. And I think a lot of these questions really require a proper engagement as opposed to just web store stuff. But anyway, this is a microneedle system. It goes transdermally through my skin. So if our materials on the web store are not biocompatible, then we're more than capable of making them biocompatible. And the questioner is aware that we're actually, we're in the medical space. We've been involved in fact, when I give my presentation today, you'll see that we've got sensors in people, in animals and on people. I've got lots of images of that today. What is the period that this sensor can be used without causing complications? I love this question. This is such an application-specific question. So this is not really a question about sensors, electronics. This is a question about, you're going to design a system and you're responsible in part for that system. So it's a question you really have to ask yourselves, not ask ZP. I mean, there's the pH sensors will in the end up being packaged into something that's essentially stops liquid ingression into the electronics. That's where you have to start talking about biocompatibility. What is the reaction time? So ZP, we're quite open. It's the same question really as the operational lifetime. We do have data on the website. What we have on the website is what we make available for free to the R&D community. These deeper questions, we would really address this in programs. So ZP's business model, we're ISO 13485. We're contract developers and contract manufacturers, and we would definitely be getting into this, these kind of questions there. Whether you need calibration is, for me, is something that we would actually develop a solution to that as part of a program. I'm fully aware that, in fact, you can't just go in and calibrate sensors that are implanted into the body. So ZP is engaged by a couple of billion-dollar businesses at the moment, and this, these are the kind of questions and solutions that we develop in those programs. Can it evaluate multiple sample types? It's just a different calibration factor for the different sample types. You say here without cleaning. See, this is really a risk register, because if you're moving a sensor around and not cleaning it, you're basically you could be causing infections. So there's more to that. There's more to this question than just do I have to clean it. The risk for me is if you move a sensor around the body, then you're potentially going to cause infection by moving infections around the body. Whether you need whether the reference electrode is sensitive to the chloride or not is really an application specific question. We're probably really good at dealing with this in a program, but just speculating wildly is a little bit hard. I'll show you some data where we do temperature characterization of our sensors, and it's probably worth saying that people think about temperature, they think about room temperature being 22 degrees Celsius, and they think about body temperature being sort of, I think it's 37 degrees Celsius. I don't want to get it wrong. The reason I bring it up is because that's the Celsius scale. A lot of science is actually done on the Kelvin scale. The Kelvin scale sort of, goodness, it's been such a while. The Kelvin scale, 0 degrees Celsius is 273 Kelvin. Room temperature, if it was 25 degrees, is 298 Kelvin. So I'm just saying that we are temperature sensitive, but on the scale of Kelvin scale, things are not as critical as people would think if they were thinking in the degree Celsius or the degree Fahrenheit scale. What is the operational time of the sensors? Could it be used for a prolonged period of 3 to 6 months? This is really an application question. I'm not going to talk about duty cycle, how often do you use a sensor? It's just, these are very application specific questions. What I would say is that we do have, data on our website that shows the sensors used in a continuous manner. And I appreciate that it's for some seconds, but when you look at our data, you can try to look for signs of degradation, but you won't find it. So really, I've said it already, but ZP is already on programs where we're doing long-term use of sensors, but these are really program questions where the people own that data. I'm not going to bring it to this forum here, but if you want to get a sense of our sensors, then the data is definitely on the website here. It's the same for here. I mean, it's when you look at it, we got so much pH data. Why? Because we've been doing it for so long. But answering the question, can you do 3 to 6 months? That's really a program question, and would be something that we would do in a program. So the program kicks off, we discuss requirements, we work against requirements or proving requirements. So that at minimum, it's a proof of principle study. I think this whole program, this whole series of questions is really at a minimum a proof of principle long-term study on a long-term implantable pH sensor. I'll put a link to that here. So if you see a link pop up, it will be underneath the webinar at the end. Lifetime in biocomplex solutions with additional ions. This is really a program-specific question. This is really a discussion about, where is this sensor going? We would. It's not something that we would just be able to sort of answer. That's really something that a team of people would discuss for several hours, and we would talk about a risk register and coming up with that. I think the question is already aware that we are already implanting biosensor packages into animals. I'm just going to hover my mouse here because this is actually, we do pH sensors also in this form factor. So I think it's good to go in the kind of planar form factor, but it's probably worth saying as well that we do have pH sensors in this form factor as well. It's quite worth noting because it's actually so tiny in this particular case. I think the length along this package here in this direction is 15 millimeters. So you can see that this is sort of sub millimeter type scale down here. Question number 3, is it biocompatible? If it is or isn't, so everything we do on the website is just really to get you going. Whether it is or isn't biocompatible is really a sort of discussion. And if we were to solve some biocompatibility, which we do a lot, I mean, this is a microneedle technology that goes on the body. We did biocompatibility studies. Solving that problem is really part of a program. I mean, here's a package that gets buried into fish. So obviously we have to deal with the biocompatibility for that. The body is a complex set of organs. Whether it causes complications or not really depends on where it goes. This is really part of the value add is, just because you want to measure something, where you measure it is important. That discussion is really part of like IP generation. I'm not suggesting you're really going to put a pH sensor in the skull, but whether it causes complications or not is really body positional dependent. And I wouldn't get into that question really unless I was on the program, because it's not just a question of like, oh yeah, it's fine, or no, it's not fine. It's actually very dependent on, well, what part of the body are we discussing here? The reaction time, really, it's in all of our data. You can look at the data. There's a link here. All of this data is continuous data, where actually the operators are changing the pH and the sensors change accordingly. So you can really just look at these profiles and you can see the reaction time. So I don't want to sort of prejudice your own examination. There's a lot of value in this data that we put freely available on the website, and so you can extract value from it. One thing I would say is that the responsiveness of our pH sensor is far in excess of what is actually required by most biological applications. Most biological applications are not changing pH that quickly, whereas our pH, and I'm not going to say it because I think you need to look at this website, you can see that the sensors change quite quickly. Does it need calibration? This is really talking about recalibration in an embedded application. This is very specific, and I would suggest it would also generate IP as well. So I think it's only appropriate really to do this on a program, not to sort of put it onto a public forum. But it needs to be a paid program, otherwise it's unclear who actually owns the IP. Problem about when you answer questions for free is the person answering the question ends up owning the IP. Can you evaluate multiple samples without cleaning? Again, this is a question that really needs to go on a risk register. ZP is ISO 13485. One of the first things you start off with is a risk register and a requirements document. I wouldn't want to, though the sensor may be fine without cleaning, you can't just assume that, because it feels to me like you may be transferring infection around the body. Sometimes I get a bit confused and think that you're actually talking about in vitro, but you are talking about in vivo. But if people are interested in using pH sensors prolonged periods and doing calibration in vitro, that's obviously easier because you can have calibration solutions and pumps, etc. But I really think a lot of this actually needs a minimum of a proof of principle study, and so I've reiterated it here and put a link here as well. Whether you need to worry about the chloride interfering with your, let's say, real signal, that's really a discussion for the program, and ZP already has solutions for it if it's required, but you don't go looking for problems you don't necessarily have. It has to really be answered as part of the program. Here, I've already talked about, don't forget that you're actually, the science behind the sensors that we use is often on the Kelvin scale. Kelvin scale is a lot less, let's say, sensitive to a few degrees Celsius changes. And we're also quite capable of doing, of checking these things. So this is admittedly a glucose sensor, not a pH sensor, but it does show you that at ZP we do have temperature control facilities. We can go in there and change temperature and watch how a sensor changes accordingly. So that's really a project question, but we have the capability of dealing with it. I'm going to slightly change course now and go ex vivo cortisol sensing. The easiest thing for us to do on cortisol sensing is actually to do it via our SensiAll platform, especially this particular meter. I would describe this as an in vitro diagnostic test. It's small, it's pretty easy to use, it's cloud enabled, and it allows multiple analytes. Again, there's a webinar on the 24th of January, sign up anyway. It might be just interesting. It's a pretty nice platform. I did sort of say that I think the whole reason for Zimmer and Peacock is getting people to at least MVP, minimally viable prototype, quickly. I should also say as well that actually everything we do is developed on platforms that are manufacturable. So we are an ISO 13485 contract developer, contract manufacturer. So we're not just trying to make things at a dead end and sort of academic R&D projects. The only reason I bring that up quickly is because actually when I'm recommending that we've got a platform for doing cortisol studies on, it's already quite productized in this particular case, and it's also cloud enabled as well. So every piece of data that's gathered on this device already goes up to the cloud, and we can change between different analytes just by using a QR code as well. The nice thing about the cloud solution is we put the raw data into the cloud as well, so it actually allows us to really do a sort of quality control on that as well. The SensiAll platform, by the way, or the SensiAll software. This is for the App Store, but we also have it on the this is for the Play Store, and we also have it for the App Store. I'll just go back slightly and linger on it so people can get their phones out and scan the QR code. The only thing about this application is it's no good to you unless you've got the hardware. But if you want to have a sense that the software exists, you can scan that. And if you're on an iPhone, you can scan this. Don't forget, you can also pause and watch that. We do have QR codes for various assays that we have. So if I just go back through these slightly, you can scan these QR codes when you've got the app, and it will allow you to flick between different assays. So you can see this kind of SensiAll platform really is a kind of powerful tool, because people have this sense that they need a different instrument for different analytes. No, this one instrument will do these different analytes. It's basically the underlying power of electrochemical assays that we're actually running. If we were doing a cortisol project, the best way we've got at the moment is the cortisol sensors themselves, the hardware, the app, the Julie database. And so you can put a sample on there, 50 microliters. The app will tell the hardware what to do. The meter will give the data back to the app. The app will actually send the data to the cloud. You will get a result, but you'll also get the raw data as well. And if you, that really helps you understand that everything's working okay. And if you so wish, you can actually share it with somebody like us as well. So that is a platform that we do have in place. So that's our kind of platform now. What these people are probably interested in is actually doing it in sweat. So the closest we got for sweat at the moment, I mean, all our cortisol sensor would similarly work, but making wearable sensors. So this particular wearable sensor here, this had like 20 million spent on it. You know, it's really hard to make wearable sensors, biosensors that are robust. You know, you do get, you know, proof of concept kind of things done, you know, for academic papers. But realistically, if you really want to then put them on people who were uncontrolled and outside of the lab situation, they're not going to function. But I'll give you an example of the kind of technology that we do have for doing sweat analysis. This came up earlier on. So, you know, people want to make sensors on the skin. That's the epidermis. We do these transdermal sensors. I wouldn't want to do this on an academic program because I think the ethic requirements about putting sensors through the skin would be pretty tough to get. We do microneedles. That's probably easier because it's less invasive. We also do sweat patches, which is much easier to get ethical approval on because you're not really penetrating the skin. And we do have implanted sensors, but that would be an absolutely terrible try to get ethical approval on that. So I wouldn't even go there. In terms of biosensors, we obviously have all these biosensors. There's really no issue if we can actually put any of these onto the body, but it's really the robustness and reliability that that you got to think about. I'm thinking about companies at the moment that are doing continuous glucose monitoring, and some of them are trying to do a fairly kind of standard hardware. They spent 100 million. You've got to be super careful with this kind of work. Anyway, talk about sweat. We do have a sweat patch. That goes onto the body. In fact, I've linked to it here. So we do have bits and bobs. We could put together a sort of proof of principle. Now, this is a particular case study where actually we took one of our lactate sensors, we put it in a sweat patch, we connected it to some electronics, and the engineer started essentially cycling, and we were collecting the lactate, and we were sending the signal via Bluetooth to the phone. I'm sorry, so the phone, in this case it was to the laptop. But this was really felt like a kind of a more sophisticated kind of academic program in some ways. The nice thing is we got all the hardware, but this setup is not something that I would just want to ship, because we had to be quite involved as the engineering team to make sure everything ran okay. But when we did run it, it worked fine. This is at the beginning, there's no lactate. This is where the perspiration starts, so he perspires, but he doesn't strain. And once he starts straining, in fact, we've got the lactate signal. And there's even a drop in the lactate during the test, which I've seen in other people's data as well. And it's basically due to glucagon around the liver kicking in and giving them a temporary kind of energy boost. But once that goes, then they actually start with the dip again. So question number 1, pH sensing in vivo. So ZP, we have a sort of buy and try. You can try very quickly by just buying pH sensors off the website, pH test solutions off the website, pH electronics off the website, and buying and trying. I think it's quicker to buy and try than to spend the engineering hours necessarily speculating. The best way of doing, especially if it's going to be implanted, is you have to really engage with ZP. We are ISO 13485. We are basically certified to do this kind of work. Question number 2, with cortisol, doing cortisol in saliva in a kind of academic type budget is more doable than trying to do it on the body. If it was on the body, we can do that kind of work, but we sort of do it at our premises where we've got all the control in the world, and if something is not working, we can run in and fix it. So to get to the kind of robustness where I have this kind of watch, this is transdermal, it's got microneedles on it, to kind of have this kind of, I'm just doing that, to kind of make a watch like this. This is it was a 20 million euro effort, and that's pretty tough, especially on academic type budgets. But there is a webinar on the 24th of January, and I would recommend coming to that. So let me wrap up with this and say, if you've got any questions as ZP, we do have a lot of technology on that website. Some simple, super things like the screen-printed electrodes to the potentiostats. But today we're getting into much more complicated realms where people are embedding technologies within the human body, and that's something that you really have to engage with an organization like us. And then the other one is quite tough because it's trying to make sensors that are wearable. But if you've got questions, please come to ZP. I'm just one of many of a team. I've got 23 years experience in this kind of space, so we do have a fair amount to be able to say on this kind of topics. Okay, thanks very much. Take care.